It's already 7:14, more than 7:10. So I think we have waited a long for all others to join. We can now start the recording now. So that will be we should start. Okay. So I'm sharing my screen now. So, okay, I think my screen is visible. Yeah, it's visible. And somebody wants to join. Let me share my screen now. Recording is going on. So somebody wants to join. So let's start session. So once again, good evening, everyone. Welcome you all to the live session 10 of NPTEL, which is non-conventional energy resources. This session is being conducted by me. I'm Rohit. I'm a PMR scholar at IT Bombay, and the course is being the instructor is Professor Pratap Haridas. He is a professor in IIT Madras. So how I have designed this live session, like all previous session, we will go through the non-graded assignments, and in these assignments we will also discuss the various questions, conceptual questions. We will take up your questions. So I have given a time of 10 minutes in the starting. So that 10 minutes is given because I expect that most of you have gone through the um, this weekly lecture. So I am pretty much sure that you must have some questions you want to interact with me. So that's why I want that key. Please raise your questions, and that questions you can raise it by unmuting your mic also, or if else you can also type in your questions in the whiteboard where I can see your questions. Okay. First, we'll take up the non-graded assignment questions. Then, in between the non-graded assignment questions, I have put the concepts and clearly explained that how those concepts are applied to those questions. After that, we will go to the grade assignment questions, and then we'll take up your question in between also, and the last session also. I also put up some concepts because this whole week was basically based on battery. I've tried to get more detail, get something extra apart from the lecture which you have gone through on the NPTEL. Okay, so let me see if somebody wants to join. Seems like most of you have. Okay, so recording is going fine. Okay, so I think so. Let me start the session now. So once again, welcome you all to this live session. The first question is in the standard electrochemical series, the potential corresponding to the hydrogen electrode is set to 0 volt arbitrarily. So first you have to basically think about these this thing, this standard electrochemical series. So what is basically electrochemical cell? The first concept which you need to know. And what is basically the hydrogen electrode or the standard hydrogen electrode that is being talked here in this question? So what is arbitrarily set to 0 volt? So if you see this statement in the standard electrochemical series, the potential corresponding to the hydrogen electrode is set to 0 volt arbitrarily. So yeah, this is actually a true statement, because we have to provide some reference to which we can measure the electrochemical electrode potential, and that For that, we take the hydrogen electrode and standard hydrogen electrode, and its value is said to be 0 volt arbitrarily as a reference point. You can say so. Uh, this is basically this is how you need to understand what are the various concepts that goes into this question, and how they are actually being uh, uh, imagined, or how the question has been framed. If you go through this type of question, you can easily solve it in the exam, and most of the question in the final exam will be something on this ground only, okay, something like this only. So first you have to be very clear about your concepts. What are the concepts which you are talking about? What are the concepts which are being asked in the question? So you need to be very clear on that. And after that concept, you can easily solve the question. So now we will see the electrochemical cell. What is the electrochemical cell? Okay. So basically, an electrochemical cell is any device that converts chemical energy into electrical energy, or electrical energy into chemical energy. Okay. So it's a basically electrochemical cell is a device which converts chemical energy to electrical energy. Okay. And it can be vice versa also. Okay, electrical to chemical. How? Can you give me an example? Yeah, rechargeable cell. What a rechargeable cell? So rechargeable cell basically takes the electrical current, and it restores the basically all the chemicals in their form, so that can be, okay, that cycle can continue and electricity can be produced. Okay, so that is the main concept behind the electrochemical cell and its operations. Yeah, it can work vice versa. It can both work from chemical energy to electrical energy, or electrical energy to chemical energy. Okay, so when you talk about this electrochemical cell, there are basically three things, or three major components that make up an electrochemical cell. So that you have to very much pretty much keep in mind when you are talking about this electrochemical cell. So one thing is that there is a solution which is compulsory. So what is this solution? So this solution is basically an electrolyte. This is uh, which facilitates the movement of ion through it, and this can be solid, liquid, anything. Okay, it doesn't mean that right has to be liquid only. Okay, so this is where the redox reaction occurs, generally at the site of electrodes. There is a conductor which exists for electrons to be transferred. So if this is a cell, this is the whole electrolyte thing. These are the electrodes, are major component of a cell, and there is a conductor which connects these two electrodes. A sign of resistance. Two electrodes are connected, so electric current flows. Okay, so this is how electrochemical cell actually operates. So this is the solution. These are the electrodes, and this is the um, conductor which is being talked about here. Okay, so I am pretty much sure that most of you have got a good idea about this electrochemical cell, how they operate. This is a very basic concept which I wanted to explain to you, that you guys can have a good grab on the topic which is being taught here. Okay, so any questions up to now? So if you have any questions, please ask. This will help you to actually build your concepts, also build your knowledge, and this will help me get a good sense about what is you wanted to ask, what is not understandable to you students. Okay, so this is the main thing which for these for which these interaction sessions has been planned. Okay. Okay, so if there are no questions, no queries, then we'll move to next slide to talk about different concepts here. I think so. Let me move to the next thing. So this was about the hydrogen electrode thing. Okay, so this question has two or three things, main concepts. So I have basically taken these two, three concepts and tried to talk about it here. So facts about the hydrogen electrode. I've tried to put some facts about hydrogen electrode. The first thing is that the cell potential of an electrochemical cell can be measured with the help of a voltmeter. Okay, so remember this device. Voltmeter is basically used to measure the cell potential of an electrochemical cell. However, the individual potential of a half cell can't be accurately measured alone. Okay, so no, you cannot measure the electrode potential of a half cell. You have to have a full cell where some electrode is working as a reference, up to which you measure the potential difference. Okay, in order to obtain the individual reduction potential of a half cell, the need for standard electrode potential rises. Okay, so this is why the need for a standard electron potential is. The potential of any half cell is calculated with respect to the standard hydrogen electrode potential, written as SHE. Hence, electrode potential of SHE, that is standard hydrogen electrode, has been arbitrarily. So remember the question, 0 volt arbitrarily. Now you know why it is arbitrarily. It has been taken arbitrarily as 0, because with 0 you can, if this is a lotto, this is a lotto, this is 0 volt. So whatever meter measures, this is the potential difference of this electrode. Okay. So to form a basis for comparison with all other electrochemical reactions, hydrogen's standard electrode potential is declared to be 0 volts at any temperature. Okay. So it doesn't mean that it's only a particular fixed temperature, that is 25 degrees Celsius, but it, at any temperature generally it is taken as 0. Okay. There are variations. I agree that there are variations with pressure and temperature, but the variations are not so much so high that it can be taken into account. But if there are large variations, then certainly that has to be taken into account. Okay. Now this is the concept. This is the basic diagram. So yeah, a standard hydrogen electrode works as anode, that is oxidized. Cathode, the other electrode is worked as cathode, that is reduced. It is connected through this wire, and there is a high voltage resistance meter. So there is a temperature, platinum surface. This is the ions, which are basically electrolyte. That is how the electrode potential, or is basically a battery, that is being seen here. It's a standard hydrogen electrode and zinc electrode as the other electrode, cathode and anode. Okay. So I think with this picture, most of the things here must have been clear to you guys. Okay. there is anything which you want to discuss here, so I'm sure there must be some something which you want to discuss. So I leave it to you guys to ask questions. I'm pretty much aware that some questions can be there, so please raise those questions, okay? And one thing is that ki I have a trick question for you also. There must be something which build up your concepts. So yeah, the standard electrode potential of calcium 2 plus ion is minus 2.87 volt, and that of F2, that is basically right, plus, I don't know, maybe iron or I don't know. Please check it. Okay, F2 is plus 2.87 volt. Tell me which electrode is good oxidizing agent and which one is good reducing agent. So yeah, there you can easily identify them. The plus sign is basically oxidizing agent. So this one is oxidizing, and the minus sign is basically reducing agent. So calcium is reducing agent. Okay, I'm sure that ki you have got a good concept here to learn. So I think after the second question is there. So yeah, please go through this. Go through this. If there are any questions, please ask. And let me see also if somebody wants to join. No. Okay, so nobody wants. Yeah, so yeah, there are actually no questions. Move to the next part. We have discussed this. Now we will move to discussing the next question here. The next question basically talked about batteries that have same voltage, use the same reactants internally. So this is basically a first statement. Why it is a first statement? We'll see. But this is basically false. Why? Because there can be many batteries. Nah, there can be different types of batteries which use a different types of reactor. Nickel cadmium battery, lead acid battery. Lot of batteries can be there. So like, that doesn't mean ki they use the same reactants. They can produce same voltage like 12 volt. Okay, this is also 12 volt. This battery B is also 12 volt. But the reactants inside these batteries can be different. Okay, this can be nickel cadmium battery. The other can be lead acid. Okay, there can be. So it's a false statement. Are you guys understanding this concept behind this? So if you are not, then let's see. Like, how does the battery work? So it has a anode, it has a cathode, and these are the ions which flow, and this is the electrode which facilitates the flow of ions. And through this wire, the current actually flows from. Okay, so these are the types of battery: lead acid, alkaline, sealed lead acid, coin battery, nickel cadmium, nickel lithium ion battery, zinc air battery, zinc carbon battery. And this is how a part of I think normal dry cell galvanic dry cell is. There is an insulated coating. The positive terminal, there is a negative terminal, and the electrolyte in it. Positive, negative electrode and electrolyte. There can be many reactors, but the voltage they produce can be same. Okay, so galvanic equation, Nernst equation through which side it is. This can be different. Okay? Please look into it. If you have any queries, please ask. Okay. Working fine. So question 3 basically talks about the electrolytes must have good electronic conductivity. Okay. So electrolyte is the first thing we need to know electronic conductivity in order to complete the circuit and enable the battery to doesn't mean कि electrolyte must have a good electronic conductivity to some battery to function. Okay, can have varying conductivity, but a battery can function properly. And this is basically a false statement. Okay, this is not a correct statement based on the uh, statement which is given. So it's basically false. The correct answer is false here. And let's see how correct. So first thing is that you need to know what is electrolyte. It's a component battery that actually helps the movement or flow of ions from one electrode to another, the redox reaction. Okay. So here if you see there are electrodes, different type of electrodes facing to the terminals, and in between is filled with between these two electrodes are electrodes. Now what types of electrolytes are there? So I've told again not have just but we have a good electronic conductivity. So the electronic conductivity come from ions. So let's see. There are strong electrolytes, there are weak electrolytes, there are non-electrolytes also. Okay. So first thing is that a strong electrolyte is a solute, or that is an electrolyte that completely dissociates in the. So the solution will contain only ions and no molecules of the electrolyte. Okay. Everything is dissociated to ions. Is H2O is basically dissociated into plus. A weak electrolyte is an electrolyte that doesn't completely dissociate in aqueous solution. Okay, it doesn't completely solution which contains both ions and molecules of the electrolyte. It will have ions also and some molecules. Okay. Weak electrolytes only partially ionize in water, usually 1 to 10%, while electrolytes completely ionize. Non-electrolytes. So we have three: strong, weak, and non-electrolytes. So non-electrolytes can be defined as substances that do not have any distinct ionic form to exist when they are dissolved. So these are the three types of electrolyte. I think you must have got this now. Solve this type of question. So, are there any tasks? Okay, guys, if there are questions, then I think good. Yeah. Okay, the next question talks about the charging at the six battery. Okay, means like there are some I have put the slides also and like one column is actually believed to take 1 hour. So if two column will take much, we just divide the 60 minutes. Similarly, if we go with this unitary method, it will take to you basically. Okay, so I think if there are any like if 5C, so you can easily now say P upon 5. So that's Okay, I think you have got this concept. Yeah, this is the C rate, basically, or the rate at which the battery discharge or charge relative to its capacity. So, one C rate discharge or charging in 1 hour. 2 C rate, as we discussed, takes 5 C rates. As you divide this by 5, it takes 12 minutes. Point 1 C rate, very slow to. Okay, then we move to the last slide. Okay, so have you gone through this? I'm sure that you have one. So if there are any questions, please ask. Okay. Okay, so now the next question is, batteries help in moderating the difference between demand and supply across the day by storing and releasing energy as required. So, what do you think about this statement? Is it a true? Is it a false? Or what can be statement? Yeah, it's quite a true statement because yeah, battery can store the excess during daytime. Just I am giving an example or anytime, and then it releases when it is needed. Basically, fulfilling the difference between demand and supply across the day by storing and releasing them. So not only this, we will see the basically different um, concepts also. Not concept, different devices, solar PV, how it is, how the battery is helping. Let's see this. Let's see this is a device. A solar panel is fitted here. So you have read about this solar panel in previous lecture, solar PV. So what it does during daytime, it stores the extra energy in battery, charge the battery. Then during night time, it supplies through inverter to all the devices. Okay, yeah, battery can fulfill the demand and supply gap because in day supply is more and night demand is more. Similarly, for wind also you can see the wind here, battery energy storage, solar PV also. So it can work in tandem with different types of energy conversion system also like wind, solar combine, okay, and battery combine, okay. Yeah. This is how it works. Okay. I would say have a look and think about something innovative or anything which you think be better. This and if there are any questions up to this because the non-grade assignment questions are over now, then I will move to the grade assignment questions and I discussed most of the concepts here, ranging from electrochemical cell, batteries, electrolyte, everything. So most of the concepts has been discussed here. Then we'll move to the this grade part of the assignment and then we'll solve each one by one. Okay, please have your questions, please ask. Okay, so let's move to the next part of this live session, which is the graded assignments questions. So basically, what I will do, I will discuss each question and then we'll give you some time so you guys can think and ask some extra questions also. Okay, so that will help you guys in. I think someone wants to join. Oh, yeah. Oh, okay. Okay. So yeah. So a battery is basically an electrochemical device. Yeah, as we discussed in the slide one or two, I think one slide, the question one. Okay, it's a electrochemical. So another thing is that it can store energy. So what a battery does, it converts like electrical to chemical and can store it in the chemical form. Not energy conversion device like wind turbine or anything. Not internal combustion device. Okay, like engines, diesel engine, petrol engine, gasoline engine. A and B is correct. So please go through this question, and if you have any queries, please raise them. Okay, now moving to the next questions. Okay, so next question is basically about most metals can undergo. Yeah, this is quite correct statement. Okay, this is why. How do we know that? So have you heard this term corrosion? Sure, you must have. So what is corrosion? Corrosion is basically enhanced by many factors like temperature, pressure, presence of moisture, salty nature, salty environment. It's basically a formation of oxide layer that is called rust on the surface. So generally on iron it form. So yeah, most metals can undergo oxidation. Very true statement. Okay. Okay, the next question is basically about when electrons in a battery move through internal circuit in an unhindered manner, then what happens? If electrons are moving in unhindered manner, no resistance is there. Okay, so it's basically a short circuit. Okay, unhindered manner are like these are two electrolytes. Electrolytes. This is electrode. Okay, electron is moving from this here, no hindered, means no resistance is there. So this is basically a short circuit. And during short circuit, what happens? Zero voltage is actually observed in the back. Okay. Okay, now moving to the next question. What happens when electrons in a battery move through external circuit that has a finite resistance? Okay. So basically, whenever there is a electrode inside that resistance, so due to this resistance, V equal to IR is actually generated, which actually reduces the voltage that is seen here. Okay, in the battery. So V minus IR is actually observed, the total resistance. So actually battery voltage is decreased. No short circuit because resistance is there, so it is not short circuit. Internal short circuit, no. Battery voltage doesn't increase. Okay, the next question is okay, so we have this 13 minutes remaining and we have to cover a large portion. We have solved this. Now we have to match this question. Match the following. So thermodynamics options are missing. Kinetics are basically how fast the reaction. Kinetics generally talk about reactions. Electrolytes should have good ionic conductivity, not electronic conductivity. Electrode are this is thermodynamics ability to reaction. And electrodes generally should have good electronic conductivity. A5 2 4 B1. The most correct number. Corrosion reaction and battery reaction are different from each other because activation barrier needs to be. The activation barrier is something needs to be decreased so that more battery reactions. So for different from each other because activation barrier needs to be actually increased in corrosion reaction because we don't want any corrosion, and it should be decreased in battery. So we want more of battery performance. Yeah, we this that the corrosion and this affected the battery performance. Okay. Okay. Yeah, let's move to question 12. The prismatic cells are better than other type of cells because arranged in parallel cells, increment extra remain between cells to accommodate selling. This they can be arranged in parallel series without gaps. Okay, so here significant extra no, they can be arranged without gaps. Okay, B, they are better suited for use in mobile application due to space constraint. Okay, so you see most of the prismatic cells in mobile application. Okay. Cells are softer in comparison to other cells. No. Okay, so the no, mobile battery cells are not soft. They are quite hard. Now we move to question 13, which says a statement and there are assertions. So you have to say about these assertions. Plating stripping mechanism is observed in lithium metal based batteries. Okay, plating strip. Assertion: it can lead to battery explosion due to short circuit. Yeah, it is right. Basically, it can lead to short circuit because of plating. This mechanism leads to dendrite formation in battery. This is also it complements the one. Okay, A and B both are correct here. Now question 14. Okay, so before I move to last two questions, let me see how much time is remaining. Then for discussion, 6 minutes are remaining. If 6 minutes are there, then can wait for some question and we'll let's see if somebody wants. Okay, so yeah, there are no questions. Then I think we can discuss here at higher C rate, lower capacity, C rate, higher capacity of battery can be. We have seen it also na at higher C rate, to around 12 minutes. At lower C rate, it took to 1 hour. Okay, so you can easily see there at higher C rate, lower capacity, and at lower C rate, capacity of battery can be extended. Similar for charging discharging. As the current drawn from a cell is steadily increased, the voltage actually, so what happens as the current is increased, so what happens to the voltage? So voltage keeps decreasing equal to vi na. So power has to be remain constant. If current is increasing, then voltage has to decrease to maintain this ratio constant. Okay, so I think with this, all the graded assignment question has also finished, and we discussed different concept, different non-graded assignment questions. So I put some slides also, like one slide in the terminology which I thought ki no. Basically, let me see if there are any questions before I take on the last slide the session. Uh, Already 2 hours. Okay, let's is the last slide. So we have this state of charge, which means percentage of maximum capacity that is remaining unused. Okay, depth of discharge, percentage of maximum capacity that has been discharged. The state of charge and depth of discharge are mostly related. Okay? Cycle life, number of cycles before the battery fails to meet performance specifications, affected by depth of. Terminologies are important. Just to have an extra slide to discuss with you guys. So if there are any questions, please write to my email or you can raise those questions. So this whole session is actually recorded and will be uploaded on YouTube. Please go through these recorded sessions. I will say it again and again. And if there are any questions, please ask them. Okay. So it has been a nice interaction with you guys. If there are any queries, please raise your questions. And okay, if there are no questions, let me end this session then. Okay. So have a nice day, guys. See you in on 18th of April in live session 11. Okay.